Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to go over how to round off answers that you derive from multiplication and division problems. So let's get into this. So remember the rule for when you're multiplying and dividing, how do you round your answers to whatever significant figures is basically the following here. So when an answer is calculated by multiplying and dividing, we are going to round off that answer to the same number of significant figures as the measurement or the inexact value with the fewest significant figures. So your answer should have the same number of significant figures as the measurement with the fewest. Okay, so that's the rule that you need to follow. So I have a couple of examples I'm going to go over. We'll set up the conversion factors, we're going to calculate them, and then we're going to round to the correct number of significant figures. So for the first problem, we have a first class stamp allows you to send letters weighing up to 1 ounce. So if you have a first class stamp, then you can send a letter as long as it's not over an ounce. Okay, so we have a particular letter that has a mass of 10.5 grams. The question is, can you send this letter with 1 stamp? So that's the problem. So now we're going to calculate the problem. So remember, when you're given a problem like this, you want to figure out what's conversion factor. Oops, excuse me. Sorry about that. So the first thing you want to do is figure out what conversion factors you can use, what can you pull out of the problem, and what relationships they give you, and also where you're going to be beginning and where you got to end. What do they give you to start with, and where do you got to go? And again, 99% of the time, this can be found in the question. The beginning of the question is the end of your problem. So here's the question: can you send this letter with 1 stamp? So here we need to find what is the number of stamps. That's what we need to find. That's the end of our problem. How many stamps can you get with 10.5 grams? So we need to find the number of stamps, because then once we calculate the number of stamps, we'll know if we need more than 1 stamp or not, right? So that is our ending. So we need to get to the number of stamps. Okay, so where are we going to begin? What do they give us? Well, you don't want to use a relationship or anything that's part of a relationship as the beginning of your problem. So if we look here, we're told that 1 stamp, 1 first class stamp, is related to 1 ounce. So we don't want to use that to begin with. The only other thing they give us that doesn't really match up with anything is this 10.5 grams. So we have a particular letter and it weighs or has a mass of 10.5 grams. So we're going to start with that. So we want to convert the mass of this letter in grams to the number of stamps that we need to mail that letter. Okay, so we need to set up our problem. So we always begin with this. So we're going to begin with the 10.5. So we have 10.5 grams. That's the mass of our letter. We're going to put that over 1. And we need to start converting. We're going to convert until we get to number of stamps. So we know that what's related to the number of stamps, we know that 1 first class stamp is related to ounces. So if we could get to ounces, then we could use that relationship to convert to the number of stamps. So let's try to get to ounces. So we're given grams. We know that 1 pound is equal to 16 ounces. If we had pounds, we could convert that to ounces, and then we could convert that to number of stamps. So, but we're given grams. We do know that 1 pound is equal to 453.6 grams, so we can use that to convert grams to pounds. So that's going to be our first step. So we're going to put grams on the bottom because we have grams on top here. So we have 453.6 grams and 1 pound on top. So 1 pound on top. We put the grams here on the bottom, so it cancels out grams here. So grams cancels out. Now we have pounds. And so now we have pounds. I'm one step further. Now I can use this relationship here. 1 pound is equal to 16 ounces. So I'm going to use that now to convert pounds to ounces. So I have pounds on the top here. So I'm going to put pounds on the bottom. So 1 pound, excuse me, 1 pound on the bottom and 16 ounces on top. So 16 ounces on top. So pounds cancel out. Now I have ounces. So now that I have ounces, I can use the relationship that 1 first class stamp allows me is equal to 1 ounce. So, so now I've converted the mass of my letter to ounces. Now I can use the 1 ounce to 1 stamp to convert to the number of stamps. So since I have ounces on top, I'm going to put 1 ounce on the bottom and 1 first class stamp on the top. Ounces cancel out. Now that I have first class stamps, I have stamps on the top. That's what I need. I want number of stamps. So now I'm done. All I need to do is calculate the answer. And when I do that, I get 0.370, 0.370370, ... So that's my answer. So I have this answer here. So this is the number of stamps that I can use. Now, this is less than 1, so I can't really have less than 1 as a stamp. So the answer would be 1. So I don't even need 1 full stamp, right? But stamps come in whole numbers, so I can't have a fraction of a stamp. So I need to round this up to the nearest whole number. So in this case, when they're asking, can you send this letter with 1 stamp? What do I round this to? So according to the rules, I need to calculate the number. I need to round this to the proper number of sig figs. So the rule is the number of sig figs in my answer should be the same as the number of sig figs in the least number of sig figs. Should be the same as the measurement or inexact number that has the least number of sig figs. So here I have 3 sig figs here. And here I have 4. This is an exact relationship. So 1 pound is exactly equal to 16 ounces. This is a English to English mass unit or weight unit. So that's going to be exact. And then here we have 1 ounce is equal to 1 stamp. So let me double check that. So this is going to be, I believe, exact. So up to 1 ounce. So this is exact. So then according to this, the least number of sig figs is 3. So if I round this, I have this 0 does not count as a sig fig. So 1, 2, 3. So I would cut off everything else and 0.370 stamps. Right. But again, in order to answer this question, the answer to this question is, can you send this letter with 1 stamp? Yes, you can send this letter with 1 stamp. Okay, so next we have this problem here. we have the re-entry speed of the Apollo 10 space capsule was 11.0 kilometers per second. How many hours would it have taken for the capsule to fall through 25.0 miles of the atmosphere? Okay, so we need to use our conversion factors. They give us the entry speed of the capsule. That's 11.0 kilometers per second. That is a conversion factor. That's a relationship between kilometers and seconds. So we're going to use that. Again, you want to use your conversion factors if they're in here or any of them that you know that aren't listed here, some common ones. But you also want to figure out, well, where you begin, where do you end? So here, what's the question? How many hours? So the beginning of the question is the end of your problem. So the beginning of this question is how many hours would it take? So we need to find hours. So we need to get to hours. How many hours? Well, where are we going to start? They gave us a relationship between kilometers and seconds. That's going to be a conversion factor. So we're not going to start with that. They gave us 25.0 miles. So that's what we're going to start with. 25.0 miles is not related to anything. They're not putting it together with anything. So it's just standing by itself. So we're going to start with that. That's what we're going to start with. So we have 25.0 miles. So we need to convert 25.0 miles to hours. So let's use our conversion factors. So here we're going to start with 25.0 miles over 1. And we need to convert until we get to time. Because hours is a time, we need to convert our miles to a time unit. We need to use this. So if we could convert to kilometers, then we could convert that. We could use this to convert to time seconds. So we're given miles. We need to convert miles to kilometers. There's several different ways you can do that depending on what conversion factors you're going to use. I'm just going to use some conversion factors that should be common to convert from miles to kilometers. So miles, I know that 5,280 feet are in a mile, so I'm going to use that. So 1 mile goes on the bottom, and 5,280 feet goes on top. So miles cancels out. So now I have feet. I know 12 inches are in 1 foot. So I'm going to use that to convert feet to inches. So I'm going to convert, so I'm going to have feet on the bottom. So 1 foot is on the bottom and 12 inches on top. So feet are going to convert. So feet are going to cancel. Now I have inches. So now I can convert to centimeters because I know 1 inch is 2.54 centimeters. So put in another conversion factor. So on the bottom, we're going to have 1 inch. On the top, I'm going to have 2.54 centimeters. So inches cancel out. Now that I have centimeters, I can convert that to meters because I know 1 meter is equal to 100 centimeters, or 1 centimeter is equal to 0.01 meters, or 1/100th of a meter. So either way works. So I'm going to put centimeters. So 100 centimeters on the bottom, 1 meter on top. So centimeters cancels out. Now that I have meters, I can convert meters to kilometers because I know 1 kilometer is equal to 1,000 meters. So we'll go ahead and do that conversion. So 1,000 meters is going to go on the bottom, and 1 kilometer on top. So now meters cancels out. Now that I have kilometers, I can now use this speed that they give me to as a conversion factor to convert from kilometers to seconds. So I know that 11.0 kilometers per 1 second. So kilometers is going to go on the bottom. So I'm going to use this. So the 11.0 kilometers goes on the bottom, and then 1 second goes on top. So now kilometers cancels out. Now I have time in seconds, but we want time in hours. So now I just convert seconds to hours using the conversion factors I know between minutes and seconds and minutes and hours. So I'm going to convert seconds to minutes. So I'm going to put seconds on the bottom. 60 seconds is equal to 1 minute. Seconds cancels out. And finally, I know that 60 minutes is in an hour. So 60 minutes goes on the bottom and 1 hour goes on top. Minutes are going to cancel out. I have hours now. So now that I have hours, I'm done. No more conversion factors. So now all I need to do is multiply by everything on top, divide by everything on the bottom, and I should get my answer. So let's get the answer. The answer is 0.001016, I think. So 0.001016 hours. Okay, so so this is the number of hours it would take for the Apollo 10 space capsule to travel 25 miles. So that's the number of hours. How many digits are we allowed to keep? So remember, the rule is that my answer should have the same number of sig figs as the measurement or inexact value with the smallest number of sig figs. So we need to eliminate or ignore anything that's exact. So here, this is the 25.0 miles I was given. That's 3 sig figs. That is not exact. That's a measure. So that's not exact. This 1 mile is equal to 5,280 feet. That's English to English length. That's exact. 1 foot is equal to 12 inches. That's English length to English length. That's exact. Here we have 1 inch is exactly equal to 2.54 centimeters. Now this is English to metric, but this is true by definition, so this is exact. So we can ignore that. 1 meter is equal to 100 centimeters. That's exact. It's metric length to metric length. 1 kilometer is equal to 1,000 meters. That is exact. Metric length to metric length. Here we have a speed. 1 second is equal to 11.0 kilometers. That is a measure that's inexact. We have a metric length to a metric time. Those do not really measure together. They don't measure each other very exactly. So that's going to be 3 sig figs here. So we have 3 sig figs here. And then, of course, 1 minute is equal to 60 seconds. 1 hour is equal to 60 minutes. Those are both exact measurements. So we ignore all of that. So we have 3 sig figs here. We have 3 sig figs here. So the smallest number is 3 sig figs. So we're going to count off 3 sig figs. Now, this one here, these zeros here are not significant. They're just placeholders. So we have 1, 2, 3. And so here we round it off to 0.00102 hours. So that is our final answer, rounded to the proper number of significant figures. I hope this was helpful. If this was interesting, helpful in any way, then please, by all means, like the video, share the video, hit that like button. Also, make sure you subscribe to my channel. Hit that notification bell. When you do, make sure you click all so you can be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. If you have a topic you want me to cover, or if you have a particular question or problem you want me to help you with, put it down below. Let me know what it is. I would love to help you solve it. Thanks for joining me and have a great day.